if either one of these equations is true, then you could have these values or these values. But if you have pi, then this expression is not defined, which means the original thing is not defined. In fact, if you look at pi here, tan of pi over 2 is undefined, right? So you have to rule out pi. Pi is not allowed. Which is more obvious if you do it in a different way. Shall we try the other identity? Some of you tried the other one and got stuck, so maybe let's see how would you pursue that further. So the other identity is 1 minus cosine x over sine x. Minus sine x equals 0, so that's the other thing you could have done here. The other form of, well, there's 3 forms for the half angle for tangent. Well, there's one involving square roots, right? Both that one possible. So what does this say? Well, 1 minus cosine x over sine x equals sine x, right? Just add sine x to both sides and then multiply both sides by sine x. Is that allowed? Well, only if sine x is not 0. Oh. Yeah, see, that presents a problem, doesn't it? Because 0 is one of our solutions. 0 does work in this equation, right? Why? Well, tan of 0 is 0, and sine of 0 is 0. 0 minus 0 is 0. So 0 works, but pi doesn't work, right? Okay, so this is a tricky one. So if you're to multiply both sides by sine x, you would not get necessarily an equivalent equation because you're assuming sine x is not 0. In fact, when you use this identity here, you're assuming sine x is not 0. Right? Because here you're assuming that cosine x is not negative 1. And those are different places, right? Potentially different places. Here, the coordinates are negative 1, 0. Here the coordinates are 1, 0. So cosine is negative 1, that's not good. But cosine can be 1, in which case sine can be 0. And over here is good, but over here is not. I don't have to tell you. Okay, so then we get 1 minus cosine x, so 1 minus cosine squared x, because we like to have the same trig function on both sides. And that says cosine squared x minus cosine x equals 0. So you can factor out cosine x. You get cosine x minus 1 equals 0. And so either cosine x equals 0, which is okay, right? Or cosine x equals 1, which is also okay. So here, here, and here are okay. This one is not. So cosine x equals 0. That says x is an odd multiple of pi over 2. So those are good. Or cosine x equals 1, in which case x is a multiple of 2 pi, which are also good, right? So if you do it this way, you get all good solutions, even though you went through a place where, you know, sine can't be 0. Even though sine is 0 in the original equation, and that's fine. If sine is 0, you're okay here, right? There's not division by 0. Here, we do have division by sine, and so those are not exactly equivalent equations. Okay, so yeah, I hope you're getting the idea that you need to be careful and check your original equation against your purported solutions, right? When you're using these identities, it can happen when you're bringing in extraneous values that are not, in fact, solutions to the original equation. So just check, make sure that it works. It's not that hard. All right, so we got a bunch more of these. In the book, there's also some online, but let's try a few more book solutions, book problems, and then we'll, after the break, we'll do some online problems. So, I don't know, what are you liking in here? How about 56? Here I've got sine 5 theta, so this is 7.5, number 56. Sine 5 theta. minus sine 3 theta. What does that make you think of?
Can you simplify or?
See, could we have used the sum to product here? No. There is, if you're using sum to product, it's got to be sine and sine or cosine and cosine, right? And here it is sine and sine. So this looks like a sum to product situation. What do we have on the right side? Well, we have cosine 4 theta, right? Okay, so we recall, or maybe we have to rebuild, right? That sine of beta minus sine of alpha, what is that?
Well,
Would that be
you
two?
could use the sum of product, but,
Yeah, and then just go backwards. Oh, this is sum to product, right? Yeah, so I'm gonna guess that this is cosine of alpha minus beta over 2 times cosine of alpha plus beta over 2, is that right? I can always check, right? This is the guess and check method.
is that what you're assuming?
So let's check this, right? So this is going to be, how do you check this? Well, half angle identity, does that work here?
Professor,
Yeah.
you need a coefficient of 2.
Oh yeah, the coefficient of 2, which belongs here?
Yeah, right there.
Yeah. So there's a couple of ways of doing this. We could say that, you know, u is equal to alpha minus beta over 2, and v is equal to alpha plus beta over 2, and then solve for, that's, if we add these up, we get alpha is equal to u plus v, and if we subtract this one from that one, we get beta is equal to v minus u. So if we were to plug those in here, yeah, it's not going to work, huh? Yeah. So one of these is sine, huh?
Yeah.
Yes.
Okay. So now let's try it. So if this is, and maybe it should go the other way about, huh? So is this the plus and this is the minus?
Yes.
Yeah.
Okay. So now let's try it. So if I plug in beta, so this would then be plus or minus here. So alpha, when I think I have to go the other way about. Beta minus alpha, right? So many different permutations of these things, right? But so then if I make this beta plus alpha, it's easier to look at it. If I finally settle on the right thing, so if I add these up, I'm going to get beta. If I subtract v minus u, I'm going to get alpha. So then if I plug in beta here, I'll get sine let's check it. Okay, so this is sine of v plus u minus sine of u minus v. What do you get? Well, this is sine v cosine u plus sine u cosine v. Right? This is sine u. Okay, so let's put that over here. Cosine v, and this is negative, so I'm subtracting this. Cosine v sine u, and oh no, I got those backwards. Sorry. Do I have it right? Yeah.
I mean, it's the right equation.
It's the right equation?
Right.
So another way to check it would be to try different values of alpha and beta. suppose they're 0 and pi over 2. Okay, if beta is 0 and sine is pi over 2, and alpha is pi over 2. Alpha is pi over 2. So we'd get, on the left side, we'd get 0 minus 1, right? Is that the same as twice cosine of, when I add these up, and divide by 2, I'm going to get pi over 4, right? So cosine of pi over 4 is square root 2 over 2. When I subtract them, I'm going to get sine of pi over 4, which is square root of 2 over 2. Yeah, looks like I got it wrong, right?
Well, so in the book,
Yeah.
it has, I'm just gonna read the way it has in the book, which is sine x minus sine y equals 2 cosine x plus y over 2 sine x minus y over 2.
Yeah, so
So you have
that's
x
pretty
plus
close to
y.
what I got. It's just, yeah, I mean, what I should do is start from basic, instead of guessing and checking, I should start